Hello everyone, I hope you're doing well. So in this video, we are going to discuss Code Forces Round 875, which was rated for Division 2. So today's contest was pretty average for me. I didn't perform very well. I did some mistake in reading the problem statement of B, like I didn't read it carefully, and in the C problem, I didn't take care of one important thing, and that was also mentioned in the announcements later. So this is the thing I missed. Unfortunately enough, they mentioned it in the announcement, so I was able to read and correct it. I believe that this must have been here because a lot of people might have this particular confusion. So anyways, after it, I tried solving problem D, but couldn't solve it during the contest, and I don't think that much time is remaining now. So let us discuss the first three problems of today's contest. The first problem is twin permutations. Now they say that we have been given a single permutation A of size n, right? So we'll be given one permutation and we have to form another permutation of the same size n. So the second permutation will be B, and we have to form it such that A1 plus B1 is less than equals to A2 plus B2 is less than equals to A3 plus B3, right? So this particular problem can be very easily solved if you just notice one particular thing. So they want that A1 plus B1 should be less than equals to A2 plus B2. If it was less than only, then you must have you will have to spend some time and effort to find the answer of this particular problem. But since it is also consisting of an equal sign, so it can be always like A1 A2 plus B2, and that can also be equals to A3 plus, so this should be 2 not 3. Then we have A3 plus B3, right? So the summation of all the values can be equal. So let's say you have 1 here at A1 position and you have 2 here and 3 here. Let's say you have 4 elements. So here you can always put 4 and their summation will be 5, and then you can put 3 here and the summation will be 5 again, and you can put 2 here, their summation will be 5 again, and then you can put 1 here and then summation will be 5 again. So at each of the positions you can put n minus a of I plus 1, right? So this will be your answer, and we were able to solve it very easily because there was an equal sign in between. So you can just make all the elements equal, and for each of the elements, if you write n minus a of I plus 1, then all of the elements will be equals to n plus 1, right? So this was a very simple observational question. So let me just show you the code how I did it during the contest. So you see that I have taken an input in a vector v of size n, and for all the values in the vector v, I have just printed n minus v of I plus 1. Right, so this would be the solution for the first problem of today's contest. Now moving on to the second problem. So this problem was not difficult, but I missed one very important thing in this particular problem. So they say that we have been given two arrays A and B of size n, and we have to merge the arrays to form another array C of size 2n, right? So you see, like, this part is very important, that how they are actually merging the array. So they are only taking the first element of either of the arrays. So either you take the first element from A or you take the first element from B, right? Now you append that particular element to the end of the array C and remove it from the array. So initially, if you took the element from A, you append it to the end of C and you just remove it from A. So let us discuss some examples first. So let's say we have some array 1, 2, 3, 4, 5, and let's say this is 6, 7, 8, 9, 10, right? So you can always take this particular element and append it at the back of C. So let's say this is the array. You can append 1 here, and once you have appended 1, you have to remove it from here. Now you have two choices, either you can choose 6 or you can choose 2, right? So let's say you chose 6, and now you will have 6 removed from here. Now you again have two choices, either you can choose 2 or you can choose 7, right? So this is how we are forming the array C. Now this is the way we will try to form an array C. Now we have to tell what is the maximum length of the subarray consisting of equal values, right? So we have to form the array C such that the length of the maximum length of the subarray is maximized, right? So basically, let's say I had some values here 1, 2, 2, 2, 4, and let's say 2, 2, 3, 5, and 6, right? So let's say we tried appending 1 to C, and we'll have it like this. See, 1 will be removed, then we can take 3 elements from A, so these 3 will be removed. So let me just write 3 times 2, and then we have 2 elements from here, so I'll append 2, and then we can append these elements in any order. Let's just say we did 4, 3, 5, 6. So you see, like, 2 is repeated 5 times, right? So 5 will be our answer. This is what we actually have to find. So basically what you can do is, since these elements have to be in consecutive orders, because for example, if you had these two arrays, right? Let's say this is 2, this is 2, this is 2, right? And let's say you had some elements before it, you had some elements before it. Here also there are some elements, 2, 2, let's say C is here and then 2, right? So you can always, let's say these are X number of elements, these are Y number of elements, you can always remove this front part, right? You can always remove this front part. You have some X elements and you have some Y elements in the array C now, or you have some Y elements before and you have some X elements in the C array, right? You can always remove this front part from both of the arrays. Now you will have a consecutive number of 2 exposed from here and a consecutive number of 2's exposed from here, right? But what is the maximum answer that you can form? You can take 3 2's from here. Let's say you appended it 2 2 2, and then you take 2 2's from here, then you append 2 2. But now you see the third 2 is here and there is a C in between. There is no way that you can append this particular 2 with these 2's, because there is a C in between, and let's say there was some other element D in between here, right? So either you will have to take D or you will have to take C. You cannot directly take this particular 2, right? So what you can do is you can independently find the maximum length of each of the elements. So for example, in the array A, there are 4 elements A, B, C and D. You can find the maximum subarray length of A, maximum subarray length of B, maximum subarray length of C and D independently. Similarly, let's say E, F, G and H are the elements in array B. You do the same thing for each of them, and you add both of the values. So maximum length, let's say maximum length in array A for some element X plus maximum length in array B for the same element X, right? You can add both of these values, calculate it independently and add both of them at the end, right? So this is what you essentially have to do. So how will you actually find the maximum length of the subarray? This is very easy. So let's say we have an array like this. Let's say we have some values 1, 2, 2, 3, 3, 3, right? You initialize your current value with 1. So current is the length of the current subarray. So as soon as you encounter like this for this particular element, you see that these two values are not equal. So what you do, you update the maximum length of 1. So let's say length of A is denoting the maximum length of any particular element in array A, right? Length of 1 will now be equal to max of length A 1 comma current, right? This is how you update the values. Now you see that the current element is 2. Okay, you initialized current with 1, right? And then you move on to the next element. You see that these two values are equal, they are not different. So you increment your value of current. Now value of current becomes 2. Now at this particular index, you will see that this value is not equal to the previous value. That means once one of the subarrays has ended. So you update the length of 2. You check what was the element previously. You update its length as length of an array A of element 2 max of same this thing as we have written earlier, right? So you do the same thing for both of the arrays, and at the end you can just add both of these values for each of the elements in array A and array B, right? So let me just show you how I implemented it during the contest. So what I have done is I have taken two vectors A and B of size n, right? Now I create two frequency maps as I have discussed. One will store the values for A and another will store the values for B, right? Now I traverse through the array A first, right? So if I initialize my current value with 1, if A of I is not equals to A of I minus 1, I set FA A of I minus 1 is equals to max of this FA A of I minus 1 comma current. So let me just quickly explain you what are these values. So FA will be a map which will store for each of the values in array A what is the length of the maximum subarray for that particular value, right? So you see that A of I is not equals to A of I minus 1, which means the subarray consisting of values equal to A of I minus 1 has ended at this particular point. So I set its length as maximum of its current length and the length of the current subarray, right? So this is the value that it is holding right now, and this is the value that I am providing right now, the value that I just calculated, right? And I reset my current with 1 and I just continue to the next two. If both of the values are equal, I just increment my value of current. At the end, since the last element would have ended at the last position, I'll update the value of the last element as max of the value that it already has and the current value. So I'm repeating it again. The map FA will store the length of for each of the elements in A the length of the maximum consecutive subarrays, right? So consecutive subarray means that all of the elements in that particular subarray will have the same elements. I do the exact same thing for the array B. It's just that I store all the values in the map FB, right? And this is the last part that I have also done here. Now for all the values in array A, I just like set my answer as maximum of answer of A and f of A plus f of fa of I and fb of I. So for, let's say there is some element x in element array A and I am taking its maximum length in array A and I am taking the same element in array B and I am also considering its maximum length in array B and I am adding both of them, right? So this is why I am doing this particular operation fa of I plus fb of I. I do the exact same thing for all the elements in array B, and the reason why I have to do it like separately for both of them, because let's say there might be a case, let me just show you. So let's say there might be a case, let's say 3 3 and 5 is here in the array A and let's say 6 is also here. So let's say 3 and 4 4 4, let's say 7 and 4, right? These are the array A and array B, right? See, so you see for the element 3 the total length will be 2 from here and 1 from here, so the total length is 3, right? For the element 5 it is 1, for the element 6 1, for the element 7 it is 1. But you see the element 4 is not present in the array A, but it is present in the array B, and so its total subarray length will be 4, which is greater than this particular value also, right? So there might be some elements which is present in one of the arrays and not present in other array, so that is why you have to take this particular loop for both of the arrays. Now at the end you can just print your answer value, and this would be the solution of the second problem. Now we have the third problem. So this particular problem was not difficult but interesting at the same time. So I would say like I found this problem interesting. So what it is saying is, initially what we do, we just draw vertex 1. So we have been given n-1 edges. Out of those n-1 edges, obviously there will be n vertices and it is forming a tree, right? So initially vertex 1 is drawn. So the first vertex is drawn, and what we do is for every edge in the input, so since we have been given the edge list, we traverse the edge list in that particular order in which it is given, right? So we will traverse the linked list in that particular order only, and if the edge connects an already drawn vertex to an undrawn vertex V, we will draw the undrawn vertex V and the edge. I'll explain you it in a while what is this statement saying, and after checking for every edge, we just go to this particular step. If all the like vertices are already drawn, we can terminate the algorithm, otherwise go to step 1. So basically we have to count the number of times this particular operation is performed. This particular operation means we are just reading through the edge list. So let me just show you with an example what this problem says, or we'll take the sample input from here. So let's say there is vertex 1, right? So vertex, initially we have this particular vertex drawn. Now we try to traverse to the edge list. So you see 5, the first two elements are 5 and 6. Neither of them is drawn, so we cannot do anything. 2 and 4, neither of them is drawn, so we cannot do anything. 2 and 7, neither of them is drawn, so we cannot do anything. Now 1 and 3 is there. So what do we do with this? We know that 1 is already drawn, so we can draw 3 like this, right? And also one very important thing, right? It does not mean an edge 1 going from 1 to 3. Even if it was written like this 3 and 1, then also you would also consider this edge and draw this particular edge like this, right? So this is the part I missed during the contest and I made one wrong summation, but this is also very important. Then even if it is written like 3 and 1, that means this is the edge, and since 1 is already drawn, you will have to draw 3, right? So let me just show you that 1 and 3 were present, so you drew 1 and 3. Now 1 and 2 is present, so since 1 is already drawn, now you draw 2. Now 4 and 5 is present, like since you have not drawn 4, you cannot do anything with this particular loop. Now you see that you have traversed the whole list one time, right? But since not all the vertices are drawn yet, we will try to traverse the list again. So let us quickly start from the starting. We see 5 and 6 are there, none of them is drawn, so we cannot do anything. We see 2 and 4 is there, so since 2 is drawn, I draw 4 as well. Since 2 is drawn, I draw 7 as well, right? Now 1 and 3 was already drawn, no problem. 1 and 2 was already drawn, no problem. Now we have 4 and 5. Since 4 is drawn, I can draw 5 from here, right? Now I have completed the whole traversal second time. Now again, since all the vertices are not drawn, I'll again try to traverse the whole list. So 5 and 6 is there. Since 5 is drawn, I can draw 6 now. This is 6. Now after this particular operation, all the other vertices, all the other edges have been already drawn. So the total number of times you needed to traverse this particular list was 3. So the answer for this particular test case will be 3. Right, this is how the problem is going on. Now I have already explained you, if an edge is like this 1 3, and even if it was like this 3 1, it would mean the same, right? So initially what we can do is we will maintain a couple of things. So the first thing that we are going to maintain is a distance array. So it is not actually going to store the distance, but it will be of size n minus 1, right? And it will be an array for all the edges, and it will store, or it will tell us in what iteration was the ith edge read. So let's say d of I will denote the iteration number, iteration in which the ith edge was made, or ith edge was read. Whatever you can say, it's both the same thing. Let's say it was made, right? So if we have this particular information for all the arrays, obviously the answer would be the maximum element present in this particular distance array, or whatever you can say d array, right? So our final answer will be the maximum value present in this particular array. Now how do we compute the values for this particular array? This is the next question. So what you can do is, I already know for all the edges which has 1 in it, right? So for example, this particular edge, let us give them some indexes. So this is index 0, this is index 1, this is index 2, 3, 4 and 5, right? So d of 3 and d of 4 is going to be 1. Why is it so? Because it has the vertex 1. It can obviously be made in the first iteration, right? Now there is one more important thing that we need to note. Since we have drawn 1, obviously I'll be able to draw 3 and 2, right? I'll be able to draw 3 and 2. Now I need to take care what are the elements connected to 3 and 2. So 2 from index 2, I can make the edge at index 1. From this particular 2, I can make the edge at index 2, right? Because this 2 is present here. Let me just change the color and show you. So this particular 2 is present at this particular position, right? And this particular 2 is present at this particular position as well. So if I have the node 2 or the vertex 2, I can make the edge at index 1 and 2, right? This is what I am saying. Again, right? Similarly for 3 also, since I have 3, there are no other vertices which I can make with 3, so I can leave it as it is, right? Now I'll check that 1 and 2 are the indexes that I can make. I am currently at the index 4 because 2 was made when I was at index 4, right? So I'll try to make these edges, but I can only make them with distance of 4 plus 1. So what I'm saying is, this particular 2 was made when I was at index 4, right? So what are all the other index edges that I can make with this particular 2? I know that those particular edges, this one and this one. But since their index is less than my current index, I can make them with the number of iterations I made the current index with plus 1, right? If they were after my current index, then the number of iterations that were required to make them would have been the same as the current iteration, right? Now let's say this particular index 4 was made using 1 iteration, and then you go to this particular point and you say that this was made during the 2 iterations. Now you see, now 2 has already been made. Now you want to make 4. So what are all the edges that you can make with the index 4 or the vertex 4? So with 4 you can make the edge number 5. So this is the last edge and edge number 5, right? So you see 4 is here, so you can make it with 4. Now since this particular edge is present after my current index, I can set the distance of edge number 5 same as distance of edge number 2, right? This is what I am saying. So what you essentially have to do is, first of all, you will have these particular edges. Their distance will be 1, initialized with 1, and for all the edges or all the vertex that you can form with this particular edge, you will try to draw them, and once you have drawn them, you will try to find what are all the other edges that can start from this particular vertex. Now if their index is less than the current index, then you will update their distance of that particular edge as current distance plus 1. If that particular index is after my current index, then you can update that their distance as current index, right? So this is what you have to do. Other than this will be the basic idea of this problem. Other than this, it's just an implementation problem and how you can implement it like using one or programming language. So let me just show you my C++ implementation of the contest. So what I've done is I have initialized my information vector, which is a pair of integers. So this particular like vector will store the inputs. So like these are the edges. Now I'm just decrementing all of them by one to store zero based indexing, and I have initialized my distance array as well. So this will be for the number of edges. That is why I have taken the size to be n-1, and now I initialize my queue as well. And I'm taking a vector of sets called pending. So pending will basically store if I have the node x, what are all the other edges that I can draw with this particular node x, right? So I'm taking two variables x and y. So x will be the first element of the edge and y will be the second element of the edge. And for each x and y, I insert the index I in both of them. Because if x and y are together, right? So x can form the index or the edge I at the ith position, and y can also form the edge at the ith position, right? So this is what I am storing in the pending like vector. Now if either x is 0 or y is 0, that means this is the first element. I push it into my queue and I set my distance of I as 1. Now I also have a boolean vector called drawn, which will store which of my vertices have been already drawn. Now I set my drawn of 0 as 1 because I have already drawn the first vertex. So now while my queue is not empty, I just traverse to the queue. I find my current edge. So this particular edge will be at the front index, and I walk my element from the queue. So this particular the information in the queue is what are the current indexes that I have to form. So indexes are basically the index of the edges. Now I try to find which of the elements now I need to draw. So at that particular index, I try to find the first element. So this is my vector storing the edges, and for that particular vector in the index, I am trying to find the first element. If I have already drawn this particular element, I set my toDraw variable to the second element of the same index. If I have also drawn the second element or the second vertex, I just continue. Otherwise, I know which element what I want to draw now. I just mark it as drawn as true. Now for all the other edges that can start from the current vertex, I just try to traverse them. If their index is less than the current index, I push it into my queue and I set my distance of that particular index as current distance plus 1. Otherwise, if it is greater, that means I can form those vertexes in the same iteration. So I also push them in the queue and I set their distance as equal to the current distance, right? At the end, I can just print the maximum element in the whole distance vector, and this is how you can solve the third problem. So I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video. And I see a lot of people who watch these videos have not subscribed yet. So if you're one of them, then consider subscribing. It's always free of cost, and you can always unsubscribe if you don't find the videos interesting later. So till the next video drops, share this channel with your friends, keep coding, stay safe, bye bye.